This video is dealing with fractional patterns or patterns with fractions. And I'm going to show you today how you can take a series of fractions, determine the rule or the pattern, and then continue that rule to find missing numbers in the series. So the first thing you need to remember when you're trying to find a pattern with fractions is that you must start with a common denominator. So in this series, in the first series, I'm going to choose a common denominator of 6. And that way I don't actually have to change the middle fractions, just the first and the last. So my whole number just stays the same. It's just kind of along for the ride. My 2 became a 6, which means I've multiplied it by 3. So if I multiply the bottom by 3, I got to multiply the top by 3. So 3.5 becomes 3 and 3, 6. 4 and 5, 6, and 6 and 1, 6 can remain, since they already have the denominator I need. And 7 and 1/2, the 2 becomes a 6, which means I multiplied it by 3. So I got to multiply the top by 3 as well. 7.5 becomes 7 and 3, 6. Now I can start to determine the rule. Now a rule includes two things, an operation and a number. And you can sometimes have a rule that will be a double operation and a number. So for example, it might be multiply by 2, add 3. Of course, fractions in this scenario, but a rule can be more than one operation. It could be a multi-step rule. This case, though, we're only dealing with a single-step rule. So first thing we need to determine is, are the numbers increasing or decreasing? And I guess I do want to add that our patterns in this case are only dealing with addition and subtraction. So if you see that your fractions are increasing in value, that means you're adding. If they are decreasing in value, that would mean you're subtracting. Ours are increasing in value, so we are adding. Now the other part of the rule is to figure out how much we are adding by. To determine the number in your rule, and this works every time, you need to pick two numbers that are next to each other in the pattern. So you could have either chosen those two, you could choose these two, you could choose these two, any two numbers next to each other in the pattern, and you subtract them. Okay? Now it doesn't matter that our rule is adding, even if it was subtraction, that does not relate to finding the number. To find the number, you always pick two numbers next to each other and you subtract them. Now, our numbers, I'm just going to pick the first two, are not in the proper order to subtract. I do need my larger valued number in the front. So now when I subtract them, 4 minus 3 is 1. 5, 6 minus 3, 6 is 2, 6. Which means my rule is add 1 and 2, 6. So if I needed to continue my rule, I would come to the last number, add 1 and 2, 6. Take that number, add in 1, 2, 6, or add 1 and 2, 6, and that could be how I can continue the rule. All right, so let me show you one more scenario that does have a slightly different twist to it. So I need to find the rule, and I'm finding a missing number, but this time the missing number is in the middle of my pattern. Still, same first step. We need to find that common denominator. I always try to use one of the numbers that's already in the pattern, or one of the denominators, so then I don't have to adjust all of my fractions. So I am going to use 6. That is a common factor for 2 and 3. So the 1/2, if I'm turning the denominator into a 6, means I multiplied 2 times 3. So I've got to multiply the top by 3 as well. 1/2 becomes 3, 6. 2/3, I'm turning the denominator into 6. So that means I multiplied the 3 times 2. And whatever I do to the bottom, I have to do the top. 2 times 2 is 4. I'll leave my blank. My last one remains the same. Now I purposely saved this one for last. It's a whole number. I need it to be a fraction though, and what we've discussed in class is that every whole number is technically a fraction. Every whole number has an invisible denominator of 1. So I can go ahead and actually turn this into a fraction. So every whole number has that invisible denominator of 1. 20 is equivalent to 20 over 1. 50 is equivalent to 50 over 1. Okay? Because A fraction is another way to write a division problem. So 1 divided by 1 is 1. My value has not changed. This still equals 1, but now it's a fraction. Now I can give it that common denominator. So I do need to have it have a common denominator of 6, which means I multiplied my denominator by 6. So now I need to multiply my numerator by 6. And my value hasn't changed. Remembering that a fraction is a division problem, 6 divided by 6 equals 1. My value is still 1. If your numerator and denominator are the same, that is equal to 1 whole. So now that they all have a common denominator, now I can determine my rule or my pattern. So first I'm going to look to see they are increasing. I went 3, 6, 4, 6, all the way to now I have a mixed number. So I'm adding because my value is increasing. And to determine how much I'm adding by, I pick two numbers next to each other. I could do those two or these two and subtract them. I'm just going to use my first two. I have to rewrite them so my larger number's in front. And when I subtract them, I get 1/6. So that means my rule is add 1/6. Now to find my missing number, it's in the middle of my series. I come to the number right before the blank and apply the rule. So 4, 6, and I add 1/6. My missing number is 5, 6. I could have also gone to the value after the blank, and I could have done the inverse of the rule. I could have subtracted 1/6, and I would have still found that same missing value.